Hello, my name is Eric Wink, and I would like to introduce the group project that I worked on for EE 3210 along with my classmates Joshua Becker, Aaron Strong, Peter Bujewski, and Donald Schaubel. Our project is on the statistical analysis of transformer insulation test data. Transformers are a vital piece of electrical equipment that are especially used in power distribution systems. They find applications in manufacturing to step up and step down voltages for the purpose of meeting specifications of different pieces of equipment. They are also used to isolate equipment from power surges and lightning strikes by decoupling them from the direct power lines. Transformers, unfortunately, can fail catastrophically, which poor insulation can again result in a catastrophic failure. For this reason, insulation is a very important topic in transformer design. In 2014, a local firm, which we will refer to as Company X, experienced a transformer blowout, which resulted in substantial production line downtime and the need to replace equipment that was damaged in the incident. This led to an investigation into the cause of the blowout, and data was collected on the polarization index of the transformer insulation. Our group took this data and used MATLAB to perform statistical analysis regarding the polarization index of the transformers and how this relates to the propensity for them to experience a blowout. I will now turn over this presentation to my classmates. Thank you very much.
Thanks, Eric, for the intro. My name is Aaron Strong, and I'm doing the background portion of this presentation. So for our data, it's taken from a large manufacturing facility with about 60 substations. Each substation consists of a switch, a transformer, and a section of breakers. And then there is some variance in the manufacturer, layout, the type of transformer, etc. So a lot of different things. Each substation is not the same. The facility has reliability engineers that perform annual testing on the medium voltage electrical distribution equipment. So that is everything that is from the power plant down to the substation. So each area or building at this facility has 1 to 3 substations, and some actually have more than that. But to ensure the functionality and the condition of the equipment, all 3 components of the substation are tested annually. And so this presentation is just covering the testing of the transformer part of that substation, and then specifically only the dry type transformers. And then even more specifically, this is only one test out of many that are performed on the dry type transformers. So we're looking at specifically the insulation resistance testing. So for this test, we use a Megger, which is a brand of equipment, and I mean there's probably 100 different things called a Megger that all do different things, but that's another presentation. So moving on, basically this piece of equipment applies a pretty high voltage, so 5 kilovolts to 1 kilovolt, performing depending on the test. It applies a voltage to the windings, and then it does its magic, and it spits out a insulation resistance based on its readings. And these measurements are recorded at 16 different times, so every 15 seconds until minute 2, and then once a minute until minute 10. So what we're looking at today is the polarization index, which is actually just the 10-minute measurement reading divided by the 1-minute reading. And there's some science behind that, but that is the gist of it. And then I just want to mention that this test is performed annually, but sometimes real-world situations prevent this test from being taken, such as production being behind and not allowing a downtime, basically. So there's a lot of sometimes holes in our data and it's probably pretty consistent, throughout manufacturing based on real world scenarios. So I will pass this off now. Thank you very much.
Transformers are a very important aspect in electrical systems. Polarization index, or PI test, is used to test the transformer insulation. So a poor insulation could be catastrophic. Transformer failures can cause a huge problem in power systems due to the fact that they are one of the most critical links in the system, and it can take a long time to replace it if it fails. So for our project, we wanted to test the sufficiency of the transformers in relation to their polarization index. Reliability of an electrical system is important to the customer or client using that electrical system. So if the system fails or doesn't work properly, the user will obviously be upset and money could potentially be lost. So for this reason, many companies with complex electrical systems hire maintenance and reliability electrical engineers to maintain their electrical system. One piece of the electrical system that these engineers must look over are these transformers, because these transformers are electrical devices. So in this project, the polarization index PI data was collected from was collected from similar transformers and was analyzed and compared with each other. So the data was collected from 2001 until 2013, which was the year before one of these transformers failed. So the data of the transformer that blew was compared to the data of the transformers that did not blow. And then plots were made to see the trends in the PI over a given period of time. And then, as well as a 95% confidence interval on the mean PI was also calculated using the data to determine what PI values should be expected. MATLAB was used to plot the data to see these trends. And then the confidence interval on the mean was found to determine the expected test values. After completing the PI tests, we can then determine at which levels of the polarization index the insulation is good or bad. And this relates directly to our electrical engineering topics, because not only is a transformer an electrical device, but also we are fully utilizing some of the aspects of MATLAB that we learn in class, as well as constructing a 95% confidence interval, which relates directly to the class. To track the cause of the failure is the first step to formulate its solution, and the origin of the defects is not simple, and generally it is a combination of many factors that can be classified in various ways.
How we brought our data into MATLAB and the steps we took in MATLAB to modify the data to be able to plot graphs from it. So, since the data we've received was in an Excel spreadsheet, the first thing we need to do is import the data. So what we need to do is we need to click Import Data under the Home tab, then find the project, the Excel sheet you're looking for, open it. Then what it does is it opens it up in a window like this. So then, instead of trying to look at all this data, which really isn't what we want to do, what I'm going to do is I'm going to select a few rows and columns that I want to look at. Particularly this time I'm just going to look at Transformer 56 and select Import Selection. So that brings the data into MATLAB. So as you can see here, here's all those values. Then, since that's a table, I really can't do much with it. I am going to convert it from table to array. And then you have to remember to include the name of the variables. And there's all my data from my table in an array format. Now, the nice thing with this is you see there are these empty cells here. We can remove those now. So if we do b equals rm missing, I can spell, what that'll do is that will remove the the rows that have empty cells in it. So there we go. Now there's the data without the empty cells in it. So what we ended up doing is we made a little bit of a script for it. So all you have to do is really select the data you want and run the little bit of code, and it generates your plot. Your plot will show your high to low polarization index for the transformer and the low to high polarization index for the transformer, as well as a threshold for if anything goes above that, it's something that needs to be looked at. The nice thing is now with this script, it's really easy. I can pick, say, another transformer and select the data we want to look at and import that data. Then I can just run this script again. It did all those steps automatically and generated the graph for that transformer. Next is Joshua talking about the conclusion of the project.
Now we're going to discuss some preliminary results that we found using our data. So some things we looked for were a spike in the PI value, which is an increase in the PI value from a good value between roughly 2 and 4 to a value over 5. A value over 5, as discussed earlier, may indicate that the insulation is brittle or cracked. And we saw a spike in the PI value in the transformer that blew the year before it blew. So the transformer blew in 2014, and in the year 2013 we saw a spike in the transformer PI value. We also saw some spikes in the PI value of transformers that did not blow. So our correlation between the PI value spiking and a blow is not 100% accurate, but we do think there could still be a correlation. And then we also looked at what a good and poor PI reading is, and we used a confidence interval to find that. So here's a graph of the PI value over time for a transformer that did not blow. As you can see, the PI value for the high to low test and the low to high test remained pretty constant and did not reach a value over the threshold of 5, and remained pretty constant between a value of 1 and 3. Now, for the transformer that did blow in 2014, as you can see, the PI value remained pretty constant for all years until the year 2013, when we see a spike, and we can see that spike on the very right of the graph. And that PI value again breaks the threshold of 5, which indicates that the insulation may be cracked or brittle, which could lead to a transformer blowing. And here's a plot of the PI value of the transformer that did not blow but also has spikes in the PI value, which makes us question if there's a correlation between the PI value spike and the transformer blow. So as we can see, this transformer had a high to low PI value that had a whole bunch of peaks and valleys and was not consistent at all throughout the years tested. And then we also looked at the PI values and what a good and poor PI value is. So from the data sheet that we got, the data sheet says that a poor PI value is a value less than 1, a questionable PI value is a value between 1 and 2, a good PI value is a value between 2 and 4, and an excellent PI value is greater than 4, but less than 5, because a value over 5 may indicate that the insulation is cracked or brittle again. So we did a confidence interval on all the transformers that did not blow to find the mean. We did that at a 95% confidence interval, and we found that the average PI value on the high to low test was between about 1.6 and 3.3, and the low end of that would be a questionable PI value, which makes us think that a questionable PI value isn't too concerning. But then again, on the low to high 95% confidence interval, we see a confidence interval on the mean of the PI to be between 1.3 and 1.6, and everywhere in that range is a questionable PI value. So again, we question if a questionable PI value is actually too concerning. So we hope you guys learned a little bit about transformers and PI values, and we want to thank you for watching.